Welcome to our first lesson of Term 2. Today we're going to be looking at linear graphs. Firstly, I wanted to go through a few important components of linear graphs. Firstly, I want to look at the x-intercept. This is the point where the line meets the x-axis, and this is written as x value, 0. Secondly, look at the y-intercept, and this is the point where the line meets the y-axis, and that's written as 0, y. And lastly, look at the gradient, which is also referred to as the slope, and this tells us the relationship of the values between x and y. There are different types of linear graphs. Firstly, we can have one with a negative slope or a negative gradient. This particular graph has the equation of y equals negative 2x plus 1. We can also have a graph with a positive slope. This one is of y equals 2x plus 1. A different linear graph, seen as a horizontal line, has no changes in the values of y, and that is written as y equals negative 2. And the last type of graph that we can see here is a vertical line, and this is where there are no changes in the x values, and this is written as x equals 1. In the next two chapters, we want to look at linear graphs written in the form of y equals mx plus c. M is the gradient of the graph, and c is the y-intercept. And we're going to look at how these two components can affect how the graph is drawn. Using these two components, we can develop an equation. So if we had our form, which is y equals mx plus c, and in our first example we have our gradient, which equals 4, and our y-intercept, which equals negative 3. So if we were to write this in the form of y equals mx plus c, it would be 4x minus 3. In our example B, we have our gradient 4 over 5 and our y-intercept of negative 2. So our form is y equals mx plus c. So y equals 4 over 5x negative 2. We're going to use this information to now draw the graph y equals negative 2x minus 1. The first step in drawing a linear graph is to draw a table of values. So we're going to do that for the values of x and y. Negative 2, negative 1, 0, 1, and 2. And we're going to fill this table using the method of substitution. I'm going to do one quick example here. So y equals negative 2x minus 1. And we're going to use the value of minus 2. So wherever there is an x, I'm going to substitute the value minus 2. So minus 2 times minus 2 minus 1. So using BIDMAS, we're going to do negative 2 times negative 2 is 4. And then 4 minus 1 equals 3. So our first value in our table is 3. And if we continued with that strategy, we would be able to fill in the rest of the table. So the next value is 1, negative 3, and negative 5. We are now going to use this to be able to draw a graph. I'm just going to add some graph paper to make our graph as accurate as possible. You want to try and use a ruler as well. I'm going to try and do it as accurately as possible here on my computer. The first step we've got to do is draw in our axes. So we've got, let's try that again, our y-axis and our x-axis. The next step is to label our axes, and now we're going to draw in our values, and you want to make sure that the spacing is even along the axes. We're going to do our negative values here. Okay, so we're going to use the table of values to now plot our different coordinates. So the first one here is negative 2 and 3. Next one is negative 1 and 1, 0 and negative 1, 1 and negative 3, and lastly 2 and negative 5. So once you've put down your coordinates, you want to use a ruler to now join the points. Again, I'm going to try and do this as accurate as possible here with my computer. And there you've got your linear equation. So you've got your equation, your table of values, your coordinates, and now your linear graph. Sometimes you are given an equation that's not in the form of y equals mx plus c. So you might need to rearrange the formula so that you're able to draw the graph a bit more accurately. So that's what we're going to do here. So we've got 3y plus 6x equals 9. So first I'm going to move over my 6x, and then my 3. I'm going to simplify. So 9 divided by 3 is 3, 6 divided by 3 is 2, and again I want it in the form of y equals mx plus c, so it's minus 2x plus 3. So from this equation I can see that the gradient is minus 2, and I'm going to write it in the form of rise over run, because that will help me draw my graph a little bit more accurately. And lastly, that the y-intercept is positive 3. So I'm going to put in grid paper, and again we're going to draw in our coordinate plane. We're going to plot the first point, which is our y-intercept, and we're going to use the gradient to find the other points on the graph. So the first step will be to draw in our axes. We're going to make sure we label them. We've got 1, 2, 3, negative 1, negative 2. Here. 1, 2, 3, and 4. Okay, so our first step is to plot down our y-intercept, which is at plus 3. And from there we're going to use rise over run to our gradient to then put in our other points. And you can do them above that y-intercept and below, and then we're going to join them up with a straight line. So we're going to rise up 2 and then across 1, and then we're going to go down 2 and across 1, and then from there we're going to go down 2 and across 1. And as you can see, I've got enough points now to join them up and draw a straight line. Obviously if you use a rule it's going to be a little bit straighter than that, but we've plotted in our y-intercept and we use the gradient from our equation to then plot in the other points and then join those together. So it's important that when you have these sorts of equations that you change them around, rearrange your formula so that they're in the form of y equals mx plus c. The next topic that we're going to be looking at are linear models. And the first example is one that you can see in the PowerPoint that was shared earlier. And this is one that was titled The Magnificent Muffin Shop. So this is where the muffin shop has a fixed cost of $100 per day. So I'm going to write that down. So it has a fixed cost of $100 per day. And then it has a variable production cost of $1.50 per muffin. So the daily cost can be modelled using the equation C equals 1.5 n plus 100. So we're going to use this equation to then draw a graph and then be able to use the graph to read off other values. So you can do this a few ways. You can do it using technology, or you could do it using the strategies that we've used so far. So the first question asks you to explain the different terms in the equation. So if we used our form of mx plus c, we can say that the gradient is 1.5 and the y-intercept is 100. I always do positive 100 so that we actually know where that would be in terms of the graph that we're looking at. So we're looking at using the form y equals mx plus c to be able to find different components which would allow us to then draw our graph. So using the graph, and if we had to draw the graph, I'm going to try and do that as quickly as I can here. So we're going to do our values. I'm going to try that line again. So along my x and y, I'm going to do, or I should say c and n. Along the bottom, I'm going to do 50, 100, 150, 200, and along the top, I'm going to do 100, 200, 300, and 400. Okay, so the first point is my y-intercept, which is going to be right here. The next point over would be 1.5, so that would be around here, and then I want to do another point around here. So my next point should be at 100 and 250, and then at 150 and 325, and then 200 and 400. So you can get those values by putting them into a table of values, or you can do that if you draw your graph electronically. And I'm just going to quickly join these up. And if I have a quick look at my graph, the other question was to find out, using the graph, what the value, using the graph to find the number of muffins produced for $220. So what you want to do is go to $220 on your graph and go across, and it should be about 80. Okay. Again, if your graph was a little bit more accurate, mine isn't very good at the moment, but if you do it accurately and you measure them through properly, you'll actually find that at a value of cost of 220, you should be able to get 80 muffins. So from a formula, we were able to draw a graph, and from the graph, we're able to then find out a value. The other option is to actually substitute that value into the formula and work it out algebraically.